Well, welcome to this Stanford Data Science Distinguished lecture here today. This is the first time I've been at an event here in this room, and it's quite amazing. The audience is very impressive, but the view of the audience is also very impressive. So it's very nice now that we've moved into this new building to actually have the ability to have the events here in this space. And it's in particular a great pleasure for me to introduce Raj Chetty, who will give this evening's distinguished lecture. Raj is the William Ackman Professor of Public Economics at Harvard, where he received tenure at an unusually young age of 28. When he was 33, he won the Clark Medal from the American Economic Association for the best economist under 40. So well before they ran out of time there. He's been an elected member of the National Academy of Science since 2018 and won a MacArthur Award in 2012, among his many other awards. Raj, together with the members of the Opportunity Lab at Harvard that he directs, has done path-breaking work on economic mobility and how it's shaped by geography. They have constructed, among other things, the Opportunity Atlas that maps the roots of affluence and poverty at the neighborhood level and shows which part of the country give young people the most chances to do well in life. They conclude that residential segregation, income inequality, school quality, social capital, and family structure are among the most important predictors of intergenerational mobility. At a personal level, I've had the great and I think unique privilege of having had Raj as a colleague, first at Berkeley, then later at Harvard, and then here at Stanford. Unfortunately, at least from my perspective, he then returned to Harvard, but it continues to be a privilege and a pleasure to work with him, the work that we started actually when we were at Harvard and continued while he was here at Stanford. For the data science scholars and students here, I want to stress something that I often tell my students. If you want to work on data science methodology, you need to read and listen to the people who use these methods to answer substantive and important questions, and who work with and gather new data. Raj is nowadays the premier example of that craft in economics. Tyler Cohen described already back in 2017 as the single most influential economist in the world today. And I don't think that's really changed since then. So I don't want to take up any more time because I may give Raj the opportunity to talk about all his work. So let me now turn it over to Raj. He'll talk for about 45 minutes, and then there'll be an opportunity to ask questions, as well as a reception afterwards. So welcome, Raj.
Right, well, thank you so much, Hito. Can you all hear me? Okay, thank you so much, Hito, for the very warm introduction. It's really a privilege and an honor here to be back at Stanford. I was very lucky to have Hito as my econometrics professor way back in graduate school. And at the time, I thought what Hito was teaching on what are now called design-based methods made perfect sense. And you'll see this, throughout my talk, something that really resonated with me and just seemed like the natural way to think about the world. What I hadn't appreciated was Hito and his collaborators really discovered and developed those methods just a few years earlier. And so that's had an incredible influence on me, as it has on many others. And likewise, I've learned a great deal from a number of people in the audience. So it's really a pleasure to be able to give this lecture. So I'm going to talk today about how we can use the tools of modern data science to understand the roots of economic opportunity in a very granular way. But I want to start at a bigger picture level by talking about the American dream, which is, of course, a multifaceted, complex concept that has different meanings to different people. But I want to distill it in this first graph here to a simple notion of the American dream that my colleagues and I, including David Gresky, your colleague here in Stanford Sociology, looked at a few years ago, where we asked what fraction of children go on to earn more than their parents did That's a cornerstone ideal of America. It's certainly the kind of aspiration that drew my own parents to come to this country and countless other immigrants. The idea that through hard work, any child can move up in the income distribution relative to their parents. So to what extent does America actually live up to that aspiration? That's the question we set out to answer, measuring the fraction of children who went on to earn more than their parents did, measuring both kids' and parents' incomes in their mid-30s, and adjusting for inflation. And so there's some statistical methodological details in the background here. There's a challenge in the sense that you don't have panel data connecting kids to parents going back historically. And so there's a question of how you can learn about a statistic like this when you only have cross-sectional distributions. And we work out some methods splitting the distribution into what's called the marginal distributions and the copula that allows us to make progress on this problem. Throughout this presentation, I'm not going to dwell on those methodological details, but I'm more than happy to come back to them in the context of questions. So just skipping that, what's the bottom line? What you see here is that for kids born back in 1940, in the middle of the last century, it was a virtual guarantee that you were going to achieve the American dream of upward mobility. We estimate that 92% of children born in 1940 went on to earn more than their parents did. But if you look at what has happened over time, you can see that there's been a dramatic fading of the American dream, such that for children born in the middle of the 1980s, who are turning 30, 35 around now in recent years, when we're measuring their incomes as adults, it's become essentially a 50-50 shot, a coin flip, as to whether you're going to achieve the American dream of moving up. So this broad trend is, of course, of great interest to economists like myself because it reflects a fundamental change in the US economy that we'd like to understand. But I would argue that this trend is also of fundamental social and political interest because it's this very trend that underlies a lot of the frustration that people around the United States are expressing that this is no longer a country where it's easy to get ahead. And that's what you see, I think, reflected in recent electoral outcomes. For instance, it's exactly in the places with the lowest levels of economic mobility defined in this way that you have the greatest support for populist political candidates. And so motivated by this trend, in our research group at Harvard Opportunity Insights, we're broadly interested in understanding what is driving the fading of the American dream and what more generally can we do to expand economic opportunity going forward, especially for kids growing up in more disadvantaged backgrounds. What can create more opportunities for upward mobility? Now, we are, of course, by no means the first group of scholars to be interested in studying that question. Analyses of inequality and mobility date back centuries across many different fields. Our angle on it is to use the tools of modern data science, very large data sets in particular, to try to get a more granular understanding of the determinants of economic opportunity, the science of economic opportunity, if you will. And so what I'm going to do in this presentation is give you an overview of what we've learned about that science, and then what implications it has in terms of potential policy interventions to increase economic mobility going forward. So let me start with the first disaggregation of the data, looking at the data, as Hito mentioned in his introduction, geographically. So let me first take a second to describe how we construct this map that I'm showing you of the geography of economic opportunity in the United States, and then tell you what I think we learned from it. So what we've done here is taken data for all children born in 1978 in the United States, so 4 million children or so, and we've obtained information from anonymized tax returns that allows us to link those children back to their parents and back to the exact location in which they grew up. Using that data, we construct a very simple measure of upward mobility. We ask, what is the average household income at age 35 for kids born in 1978 who had low-income parents? And for the purpose of this talk, I'm going to define low-income parents as parents at the 25th percentile of the national income distribution, which corresponds to a household income of about $27,000 a year. So concretely, if you take the kids who grew up in the Bay Area, for example, what we see in the tax data is that if you take the set of children who grew up in families making $27,000 a year, on average, when we look at their 1040 tax returns, when they file them when they're 35 years old, they're making about $37,000 a year, okay, as you can see there. Similarly, we can construct that statistic for all of these 740 different metro and rural areas in the US, and we color the map so that the red-orange colors represent places with lower levels of upward mobility, where you're less likely to achieve the American dream, and the blue-green colors represent places with higher levels of upward mobility. So if you start by just looking at the scale in the lower right-hand side of this map, you can see that there's an enormous amount of variation in children's chances of rising up across different parts of America. There are some places, like if you look at the center of the country, a place like Dubuque, Iowa, for example, kids growing up in families making $27,000 a year, on average are making $45,000 or even $50,000 a year in the next generation, a substantial amount of upward mobility in a single generation. Yet there are other places in America, take Charlotte, North Carolina, for example, where kids growing up in families at that exact same income level of $27,000 a year are making much less, actually less than their parents were in their mid-30s, which is kind of remarkable if you think about it, given the amount of economic growth that has occurred in the United States over the past 30 years. And so you can see the broad geographic patterns here for yourself, much lower levels of upward mobility in the Southeast and cities in the industrial Midwest like Cleveland and Detroit and so on, higher levels of upward mobility in the rural Midwest and parts of the coast. So this map, I think, is of interest for a couple of reasons. First, from a scientific perspective, it gives us a new lens, essentially a microscope, to study the determinants of economic mobility that we haven't had in the past. So prior studies, often made comparisons across countries or across different time periods. Of course, there are hundreds of things that are different about the US back in 1950 versus the present, or European countries versus the US. At this level of granularity, you can start to ask, what's different about Minneapolis versus Charlotte? What happens when a kid moves from Charlotte to, say, Boston? And that, as I'll show you in the next few minutes, can help us start to understand the determinants of economic mobility much more precisely. Second, and maybe more importantly, ultimately from a practical perspective, once we have that understanding, we can potentially make interventions in the red-colored parts of the map that can help us increase economic mobility in those places and thereby expand economic opportunity for everyone. So motivated by that two-part logic, the way I'm going to structure this talk is first spend some time giving you an overview of what we've learned through our own research in our group and many other scholars about the determinants of economic opportunity, and then talk about potential policy interventions to increase mobility going forward. Now, one step in starting to understand the determinants that was important in our own thinking was to recognize that these differences that we're seeing in this broad map, where your eye naturally gravitates towards differences across regions, the Southeast versus the Midwest, and so on, actually emerge at a much more granular level. So to show you that, let me zoom in to show you the same exact statistics now at the census tract level here in the Bay Area. And let me just note for those who are interested, you can go to a website, the Opportunity Atlas, opportunityatlas.org, and type in your own home address if you're interested and look at the statistics for your own neighborhood. So what we've done here is the exact same calculations that I was showing you before, but now we're reporting these statistics at the census tract level. Every census tract in America has about 4,000 people. So think of this as a very granular definition of neighborhoods. And so what you can see here in this map is that these differences in economic mobility are originating at a very local level. So take, for example, East Palo Alto versus Redwood City. You can see that there are dramatic differences in children's chances of rising up. In fact, the spectrum of colors that you're seeing on this map looks exactly the same as the spectrum of colors you see on the national map in the previous slide, and we haven't changed the color scale. So basically what that's telling you is you can drive a few miles down the road in the Bay Area, and it's like you're going from Alabama to Iowa in terms of your chances of rising up as a kid. So that simple observation, I think, is an extremely important one because it suggests that the roots of these differences in economic opportunity are not entirely about state-level differences in policy or differences across labor markets in different cities. No, it's often about what's happening on one side of the street versus another side of the street, East Palo Alto versus Palo Alto, Redwood City, et cetera. And that very local difference maybe makes you think about a different set of factors, things that vary at that very granular level, perhaps things like the quality of schools, who you're connected to, et cetera. And so motivated by this, this set of descriptive findings, what we next did, I want to show you one final set of descriptive results before starting to show you what we think the determinants are, is start to look at how these kinds of patterns, which were for kids born in 1978, how these patterns are changing over time. So in our most recent work on the geography of opportunity, we've been analyzing how economic opportunity is changing over time in the United States. So when we first started doing this research, we were able to look at kids born back in 1978 in that first map that I showed you. Now about 10 years have passed since we put out that first study on the land of opportunity, and basically because of the gift of time, we're able to start to look at how these maps are changing over time, which turns out to be quite illuminating as well. And so to show you what that data looks like, I'm again going to start with the data back in 1978. And here it turns out to be useful to also cut the data by race. So here I'm specifically showing you the data for white kids born to low-income parents. And you see a map now shown at the county level that looks similar to what I started out with, right? Redder colors, lower levels of upward mobility in the Southeast, higher levels of upward mobility in the Midwest and the coasts, and so on. So this is for kids, white kids born to low-income parents in 1978. Now let's replicate the same exact map for white kids born to low-income parents in 1992. And what do you see? The red colors have basically spread across America, opportunities receding for white children born to low-income parents. It used to be the case that in California or parts of the Northeast, you'd have a pretty good shot of reaching the middle class if you were a white kid growing up in a low-income family. That's no longer true. White children growing up in many parts of California have the same shot of reaching the middle class or doing well as kids born in Appalachia. And so opportunity is really falling quite substantially for white children growing up in low-income families. Now, why did I cut the data by race? If I now show you the same exact patterns for Black Americans, now here we've changed the color spectrum for a reason that'll become evident in a second. Purple colors are places with lower levels of economic mobility here. The peach-orange colors are places with higher levels of economic mobility. A lot of the map is blank because, as you know, there isn't a substantial Black population in much of the United States to construct these statistics. But where we can construct them, we again see significant variation in rates of upward mobility across places with lower levels in the industrial Midwest and so on. So again, these data are for 1978. Now let's replicate that map for Black kids born in 1992. And what do you see? Actually exactly the opposite pattern of what I showed you for white kids. Rates of upward mobility are going up systematically across places for Black children being raised in low-income families. And so that's positive news. It suggests that these long-standing racial disparities are narrowing, in part because outcomes are improving for Black Americans. But there's one final point I want to emphasize here on this descriptive set of facts on the geography of opportunity, which comes simply from juxtaposing the two maps that I showed you for Black children and white children born in 1992. This is just the data that I showed you before, but what you see very saliently here is even in 1992, when things have improved for Black children and deteriorated for low-income white children, you still see an enormous divide in economic opportunity by race. The very best places for upward mobility for Black children have worse outcomes than the very worst places for upward mobility for white children. You essentially have two non-overlapping distributions, as you can see here. And so this set of facts on how opportunity is changing, to me, really capture some of the fundamental narratives that we're seeing in the United States at the moment. On the one hand, it is true that opportunity is receding for one group, for white kids growing up in low-income families, and that's clearly creating a lot of consternation. On the other hand, it's also true that there remains an enormous divide by race and economic opportunity if you focus on the levels, as you see in the slide. And I think that reflects some of the tension, different people focusing on different aspects of that problem that are part of the public discourse today. And so motivated by this set of facts, I think this makes it all the more important and interesting to understand what the determinants of economic opportunity are. Why is it that economic mobility varies so much across places? What drives these changes over time? Why are there differences across racial groups? And so on. And so that's what I want to turn to next. So how can we learn about the determinants of economic mobility? What I'm going to start with is a simple analysis that compares outcomes across areas and asks, to take the example I gave you locally, why do outcomes look so much better for kids growing up in families with comparable incomes in Redwood City versus, say, East Palo Alto. And so as a starting point, a fundamental question you might ask, which goes back a long time in social science, is how much of this difference that we're just seeing observationally in this map is due to the causal effect of growing up in Redwood City versus East Palo Alto, versus simply the fact that it might be a different mix of people who are living in one neighborhood versus another neighborhood. So this relates to essentially the age-old debates about nature versus nurture. How much does social environment matter? Questions that have been discussed in sociology for a long time and other related fields. And so what we've done, our group and a number of others since then, have essentially thought about methods of randomly allocating or quasi-randomly allocating children to different neighborhoods in terms of their levels of economic opportunity, and seeing in the context of this example, if I were to run an experiment somehow and essentially have a bunch of kids grow up in Redwood City instead of East Palo Alto, randomly assigned, would I in fact see differences in their outcome in adulthood? And so just to give you a flavor for what that evidence looks like, this is an example from a very widely studied experiment called the Moving to Opportunity experiment, which some of you might be familiar with, where what they did back in the 1990s is essentially took about 5,000 families, split them randomly into 3 groups. One group, the control group, was simply given the opportunities to stay in the high poverty public housing projects where these families lived initially. A second group was given what were called at the time Section 8 vouchers, so unrestricted housing vouchers to move to different neighborhoods, typically lower poverty, higher opportunity neighborhoods. And then there was a third group that they called the experimental low poverty voucher group that was given a restricted set of vouchers that had to be used in census tracts with less than a 10% poverty rate. Think of it as census tracts that look more like the blue-green colored census tracts that I've been showing you on the prior maps. And so essentially what we're doing here is relating the experimental data where we link the moving to opportunity information to the tax records and track children who moved at young ages to these different neighborhoods and follow them over time. We ask, what did their earnings look like in adulthood? That's what's plotted on the vertical axis, against what we would have predicted based on the observational data in the Opportunity Atlas, what I just showed you in the previous maps. And what you can see from this very simple comparison is that indeed, in the Opportunity Atlas, you would have predicted that the kids who moved to these neighborhoods that have lower poverty rates in the experimental voucher group, that they would be earning about $3,000 more. And in fact, when you look at their, you follow those kids who were randomized, you see that in fact, they were indeed earning about $3,000 more down the road. And so this is one example of, combining experimental and observational data, a theme that I'm going to come back to repeatedly in this lecture, which I think can be really useful in the era of modern large data sets, where essentially you can view the experiment as validating the observational variation as containing some information about the causal effects of neighborhoods. Now, this particular experiment, it has a sample size of 5,000 people. It's a pretty big experiment by standard social science norms. But you could see that you get fairly wide confidence intervals, just given that earnings are a noisy outcome. So there have been a series of studies that now use much larger samples using quasi-experimental methods, tracking millions of families that move across neighborhoods, looking at comparisons between kids who move at younger versus older ages, sibling comparisons within the same family, families displaced by natural experiments, shocks that occurred for other reasons. And they all find very similar patterns, a dozen or so studies, that essentially if I quasi-randomly allocate kids to the blue-green colored areas, I see better outcomes, especially if they move to those places at young ages. So motivated by that fact that we know that at least a significant portion of the variation in these maps that I've been showing you reflects something about the causal effects of environment, it's interesting to ask what is different about the places that systematically seem to produce better outcomes relative to places that produce worse outcomes. Now, there's a very large literature now that takes the Opportunity Atlas data and relates it to a number of different factors, and people have discovered lots of interesting things. I'm going to summarize here in the interest of time the 4 strongest patterns that we see in the data. First, just from a correlational perspective, we see that places that produce higher levels of economic mobility tend to have lower poverty rates. They tend to be more mixed income neighborhoods rather than places that are very segregated by income. Second, they tend to have more stable family structures. They tend to have more two-parent families, for example. Third, as you might expect intuitively, they tend to have better schools, both at the K through 12 level and in terms of access to higher education. And finally, they tend to have greater social capital. Now, this notion of social capital is something that's been discussed in the social sciences for a long time, more than 100 years. People have meant many different things by it: the strength of community, who you're connected to, how cohesive a community is, and so on. In economics, I think it's really your colleague in the economics department, Matt Jackson, who's pioneered the idea that social capital and networks may be very important for economic outcomes. And so in some recent work, Matt and I, with several other collaborators, set about to again use the tools of modern data science and big data sets to try to measure social capital and its relation to economic mobility in a more precise way than has been possible in the past, in particular through a collaboration with Meta, the company that operates the Facebook platform. We constructed granular measures of social capital for every zip code in the United States. And I'm going to focus on one of them here that appears to be particularly important in driving economic mobility. So just to walk you through the slide, the map on the left is the same map of upward mobility based on tax data that I showed you from the beginning. The map on the right is completely different. It's a map of what we're calling economic connectedness, one measure of social capital. The way it's defined using Facebook data is to take the set of people with below median income on Facebook and ask what fraction of their friends have above median income. So the blue-green colored places in this map on the right are places where low-income folks have more high-income friends. The red colors are places where you have more disconnection by class, where low-income people don't have many high-income friends on Facebook. And you can see immediately the remarkable similarity between these two maps. This turns out to be the single strongest predictor of economic mobility that we or anybody else has identified to date. And remarkably, it also explains a number of other patterns that people have found in the past, that places with more inequality, for example, have lower levels of economic mobility. This appears to be the key mediating factor that explains that relationship. Places with more inequality tend to be more disconnected socially, and in a statistical sense, that fully explains the link between inequality and economic mobility that's been documented in prior work. And so our sense is, both from a predictive perspective and based on some ongoing work we're doing with other collaborators, that there's a strong causal link between these cross-class connections and economic mobility. If you use quasi-experimental methods, for instance, arising from fluctuations in who you're exposed to in school across cohorts, you happen to be in a cohort where there are more high-income children, peers with high-income parents in your cohort, you tend to have better outcomes in the long run. And so that kind of evidence really makes us think that this notion of economic connectedness and social capital is extremely important as a determinant of economic mobility, perhaps because it changes access to jobs. Many jobs in the US are obtained through referrals, or maybe at a deeper level, because it changes children's aspirations. So for instance, if you've never met anyone who's gone to college, maybe you don't think about applying to college. If you've never met anyone who's gone into science, that may not be on your radar screen. If you're in a community with more of those cross-class connections, it might change what children end up doing. We don't quite know what the underlying mechanism is yet, but what seems quite clear is this is an extremely important determinant of economic mobility. It certainly shaped my thinking on what kinds of policies can matter, and you'll see me come back to that theme a couple times now as we move towards talking about interventions to increase economic mobility. And so on that note, I've given you, just a quick overview here of what we think are the drivers of economic mobility. In the second half of this talk, I want to discuss how we can take this type of understanding to make concrete changes that can increase economic mobility going forward. And so the way we are organizing this work in our team at Harvard is to basically focus on 3 different policy approaches that I think follow naturally from the set of results I've shown you on the determinants of economic opportunity. So to summarize in a nutshell, what I think we've learned from a decade of research on this question, our sense is that the determinants of economic opportunity are hyperlocal. It's about the neighborhood in which you grow up, something from birth till you're 22 or 23 or so. Something like a 1 mile radius around your house. What's going on there seems really important. The schools that you're attending, who you're connected to, and so on. So if you have that theory of the world in terms of what the drivers of mobility are, I think you would naturally think about 3 different ways to increase mobility going forward. The first is to reduce segregation. If I know that there are better opportunities a couple miles down the road, maybe I can help more low-income families move from a place like East Palo Alto to other nearby neighborhoods through housing vouchers or other affordable housing programs that might give them better access to opportunity. So that's one possibility, sort of a moving to opportunity approach. Now, of course, that moving to opportunity approach may be helpful for a small set of families, but it's not fully scalable. You can't move everyone from one neighborhood to another neighborhood. And if you tried to do so in general equilibrium, you presumably wouldn't get as large effects in any case. And so I think you have to, at a minimum, complement that approach of reducing segregation with what you might think of as a place-based investment approach, where we try to take the red-colored places in the maps that I've been showing you and turn them into green colors by making investments in those places, revitalizing those neighborhoods in some way. So that's a second, I think, important approach to think about. The third approach is recognizing that after age 18, the key touch point for most kids is not the home in which they grow up, but the institution of higher education they attend. I think that there's a lot that we can do in our higher education system in the United States to make it more effective at promoting economic mobility as well. Now, one could give a whole talk, and there's a whole literature in each of these areas. What I'm going to do in this evening's lecture is focus primarily on the third set of issues, partly because I think it's relevant here at a place like Stanford. It's also a place to illustrate some methodological issues that I think might be of interest to this group. But let me briefly mention, just to give you a flavor, some of the work that we're doing in the first 2 areas before concentrating principally on the third. So to give you a sense of the types of things, the ways that we can use data to improve policy in the affordable housing space, let me turn to this map here. So again, a snapshot from the Opportunity Atlas of the Bay Area in terms of rates of economic mobility that I showed you before. What we've done here is overlaid in the black dots the most common places where families receiving housing vouchers from the federal government currently live. To give you a bit of institutional context, in the United States, we spend more than $50 billion per year on various affordable housing programs that are intended to give families access to more stable housing in better neighborhoods and so on. The largest component of that expenditure is what's called the Housing Choice Voucher Program, which gives about 2.5 million families subsidized rent. So think of it as in the Bay Area worth about $1,500 a month of subsidized rent to find housing wherever you want. Now, when you look at this map, you might notice a puzzling pattern. Despite the fact that these families are receiving $1,500 a month of rental assistance, these dots are concentrated primarily in the red colored parts of the map, not in the blue-green colored parts of the map, which, as I've emphasized earlier, are the places where families actually have a good chance of breaking out of poverty. So despite the fact that we're spending billions of dollars on this program, I don't think it's actually effective in helping families move to neighborhoods where they're likely to break the cycle of poverty in the next generation. So you might ask, from an intellectual perspective, why is this the case? Is it that there's something that's preventing these families from moving to these higher opportunity areas? Some sort of barriers that are frictions that are preventing them from making these moves to opportunity, despite the fact that they can afford different neighborhoods with that rental assistance? Or is it that they have preferences to stay in the red colored parts of the map, not because they don't care about their kids, but because there are other reasons that people might want to stay in those neighborhoods. It's closer to their jobs, easier from a transit perspective, closer to their friends, et cetera. So we set about to assess which of these things is going on and try to think about whether one can design more effective policies to help families move to opportunity. And in particular, we did that in collaboration with the Seattle and King County housing authorities, where now I'm showing you a snapshot of the Opportunity Atlas data for Seattle, where you see exactly the same checkered pattern, lots of differences in outcomes across areas, same pattern of the black dots being clustered in the low opportunity neighborhoods. So we collaborated with the local housing authorities to set up a randomized trial, again, going back to a different tool here to study this question, where we took about 1,000 families that came in to apply for housing vouchers through the standard approach and essentially tested what I think of as a social capital intervention informed by in some ways by the work with Matt, where we asked, if we give families support in the housing search process, don't just give them the financial assistance of the voucher, but connect them with a counselor who would help them find housing in a high opportunity area if they wanted to, look up listings and say, here's a place in a neighborhood where we see kids doing well, which might work for your job. I'm going to connect you to a landlord there. I'll come with you to negotiate with the landlord. If you need money for a security deposit or an application fee, we'll provide that. So basically shepherd you through the housing process in a way that would be very familiar at the high end of the housing market, where there are lots of brokers who want to help you. At the low end of the housing market, that basically doesn't exist. So think of this as trying to provide that kind of social assistance in the search process. Ran this as a randomized trial. 500 families or so got this assistance. 500 families just got the voucher, didn't get any of that additional assistance. Follow those families over time, ask where do they end up living. In the control group, 14% of families moved to high opportunity areas as defined by our Opportunity Atlas measures. In the treatment group, you can see that number jumps up to 54%. So it's quite a significant shift in terms of where families end up choosing to live in Seattle. Now, in understanding the magnitude of this effect, I think it's important to contextualize with two numbers. First, this intervention is not cheap. It costs about $2,500 per family. So that's undoubtedly a significant sum. However, relative to two benchmarks, I think it's actually a very small number. On average, we spend about $100,000 per family on these vouchers. Remember, it's $1,500 a month, typically for a decade that a family stays in these units. So relative to that existing cost, it's a 2% incremental cost. Maybe more importantly, we estimate that the kids who got lucky and ended up in the treatment group, based on our prior work, they're going to earn about $200,000 more over their lifetimes relative to the kids in the control group. And so the rate of return on that marginal investment is incredibly high. In an era where people are interested in improving the efficiency of government, this seems like a very valuable investment to make. And so this kind of work, I think, can be quite valuable as a way to increase economic mobility. I'll talk at the end about how this sort of approach is being scaled more broadly. But I also want to acknowledge that by no means can this really be the solution to increasing economic mobility, because you can only do this at a certain scale. And so in some other ongoing work, coming back to the map here, we're taking sort of the opposite approach of thinking about, rather than bringing people to opportunity, can you bring opportunity to people where they currently live? And so in some work I'm doing with your colleague, Rebecca Diamond in the business school, as well as other collaborators, we're studying a large-scale program called the Hope 6 Neighborhood Revitalization Program, which we're finding has really significant effects, where they essentially demolished high-poverty public housing projects, tried to turn them into mixed-income neighborhoods. Over time, that really seems to promote opportunity in those places. That's a study that we'll put out later this year, and seems to suggest that this place-based investment approach can also be quite valuable. And I'm happy to talk more about that when we open it up for discussion if folks are interested. So in the remaining time, I want to focus on what we can do in the education sphere to increase economic mobility. And so to set the stage for that, I'm going to start with this set of data here, where very similar to the data that our team has constructed on how economic mobility varies across each neighborhood in America, we've also constructed statistics on how economic mobility varies across colleges for every college in the United States. And when you think about colleges' contribution to economic mobility, there are two dimensions that matter. On the y-axis here is what we're calling the upward mobility rate. So we're asking, if you take the set of kids who start out in low-income families, information's again coming from tax records linked to other government data. So take the set of kids starting out in families in the bottom 20% of the income distribution. What fraction of those kids, when we follow them 10 years after college, end up in the top 20% of the income distribution? So if you look at Stanford, for example, that number is close to 70%. The vast majority of kids who come from low-income families at Stanford end up doing very well, reaching the upper middle class or beyond. But of course, what matters for a college's contribution to economic mobility is not just how well low-income kids on campus do, but how many low-income kids you have on campus to begin with. And that's what's shown on the horizontal axis, the fraction of students from families in the bottom 20%. And here you can see places like Harvard and Stanford, Yale, and MIT, despite many efforts over the years to expand financial aid, to do more outreach, and so on, still have something like 3 or 4% of kids coming from the bottom 20% of the income distribution. And so mechanically, as a result of that, there's no possible way that these institutions can be contributing a whole lot to economic mobility. There just aren't that many low-income kids on campus to begin with. Now, at the other end of the spectrum, right, every dot here represents a different college in America, and we've labeled some colleges in California here. You can see that there are other colleges, for instance, San Joaquin Valley College, that does educate many kids from low-income families. But unfortunately, when you look at these dots over on the right, the outcomes don't look so great, right? So you don't see children reaching the upper middle class after attending many of these colleges. And so one way to conceptualize what I think the core problem is in the American higher education system in terms of promoting economic mobility is that there are basically no dots in the upper right side of this chart. There are very few places that both educate many low-income kids and deliver excellent outcomes after college. And so one way to conceptualize what the policy problem is then is how you might first move these dots up, make these colleges more effective in their training essentially, and how you might move those dots on the upper left to the right, how you might expand access to places like Stanford or Harvard, et cetera. So what I'm going to do in the remaining time is show you some results and ways we've been able to make progress on both of these dimensions. So on the first of improving outcomes, one way that, just in the descriptive data, you can start to get clues about what might make a difference is to look at the few outliers that are on this chart. So let me highlight one of them that's illustrative. It's the Vaughn College of Aeronautics and Technology. It's a very small college in Queens, New York, that does exactly what you'd think from its name. It trains you in aeronautics. It's a kind of place that enrolls lots of kids from lower income families. Because aeronautics is a profession where you get paid decently well, lots of people end up in the upper middle class. So you can think of that as like sort of a modern version of vocational training. In the US, as I'm sure you all know, there's a tradition of focusing on broader liberal arts education and less of this vocational sort of approach. This is maybe a clue that doing something like this could be a productive way to increase economic mobility, at least for some subset of kids. So let's think about whether we can do that more systematically. And the way that I'm going to do that is to focus specifically on a set of workforce training programs. And in particular, I'm going to focus on what are now called sectoral job training programs that try to do something a little bit like the Vaughn College of Aeronautics. They give you skills to get a job in a particular sector like IT or health or financial operations. And so the way this Year Up program works that I'm going to focus on as a case study is that it's a 1-year program where you spend 6 months getting a certain set of skill training, like traditional job training programs that have been implemented in the past. But then critically, there are 2 more elements that I think, again, connect back to what I would think of as a social capital or networking approach. Rather than just saying, as traditional job programs did back in the 90s and 1980s, we're going to teach you a certain set of skills. We think this is going to be valuable in the job market. Good luck finding a job. Instead, they're saying, we're going to link you up with an internship at a specific firm. It might be Citibank or Bank of America. You're going to do that as part of this program. And if that goes well, our sense is there's a job waiting for you at that particular firm. And so giving you a direct connection and mentoring and so on that tries to, in addition to these technical skills, give you the social capital in some sense to make this career advancement. So why do I emphasize this particular program? It turns out in a randomized trial, people have evaluated the effects of year up. So there was a randomized trial run back in 2014 where they took a couple thousand people, half of them were given access to year up, half of them were not. The treatment group is shown in green here. The control group is shown in orange. You can see prior to participation in the program, as you'd expect given randomization, the earnings profiles of these two groups track perfectly. Then the treatment group enrolls in year up, participates in this program. While you're participating in the program, you are working less, and so your earnings fall relative to the control group, as you'd expect mechanically. And then you can look at what happens afterward. Earnings surge for people who participated in year up and remain high in a constant way with about a $9,000 a year earnings gain that persists, indefinitely as far as we can tell afterward. Okay, so that looks like a very promising program. So I now want to spend a few minutes talking about a set of methodological issues here that I think are actually fundamentally reflected in some of Hito's work and many others here about causal inference, where I want to think about what we can learn from this randomized trial and what it means for policy going forward. So one way to look at this is that we've run a randomized trial. We know this program works. Let's do this everywhere. And that would kind of be a conventional approach that we might take, especially if you were in more biological science where you think you have a pill that has a certain treatment effect and you think that treatment effect is very stable across settings. That may make a lot of sense. My sense is in the social sciences, in the kinds of problems we're talking about here, that is not a good assumption of stability of treatment effects. And so it's very useful to be able to estimate treatment effects in different settings and different time periods and so on. Now the challenge in doing that is that, as you all know, running a randomized trial, while it's great when you can run it to get this sort of gold standard evidence, it's very costly, very difficult to run a randomized trial in every city, in every time period, in every possible set of conditions, et cetera. And so an alternative, which people have been interested in a long time, going back to the 1980s, is to use observational estimators, matching methods, for example, to try to estimate these treatment effects. And there's been a long history of trying to see whether those matching estimators or propensity score estimation, regression, various observational techniques, can they reproduce what you get with an experiment? There's been a lot of debate about that and so on. So in some recent work we're doing with Larry Katz and Jim Reisinger and Kadim Noureh and other colleagues, we've been investigating whether in the age of big data, these types of matching and observational estimators may have a better chance of working. The logic is that when you have enormous data sets, perhaps you can find better controls than you would be able to in the smaller data sets that people like Bob Lalonde, for those who are familiar with this literature, were working with back in the 1980s. And so to give you a concrete sense of how that works, it's really a very simple idea. What we're going to do here in the black series is implement what I call a matched control approach, where the logic is extremely simple. We're going to take, for every person who participates in this Year Up program, find somebody in the tax data where we're using data on the entire population, 170 million people, 170 million adults. We're going to find all the people of the exact same age, same sex, same race, living in the same state, who had exactly the same earnings profile in the prior 3 years before they participate in the program. And we simply plot their earnings in the black here. And you can see that remarkably, that earnings profile almost exactly matches what you see for the experimental control group. So one way that you can think about this is that even without running the experiment, if you had implemented this matching approach, you would have seen exactly the same difference between the treatment group and the control group, which looks very encouraging for this methodology. As another way to see that, if we take the matching method that I just showed you, take the difference between the two series that I showed you, the treated group versus the matched control on the previous slide, and plot that difference in earnings over time, we can see that before people participated in the program, there's zero difference between the two groups. When they participate in the program, earnings dip in the treated group relative to the matched control, and then afterward they go up by about $9,000 a year. There's a $9,000 a year treatment effect in subsequent years. If I overlay what you get from the randomized control trial for that exact same set of comparisons, exactly as you'd anticipate from the previous slide, it very closely matches what you get from the matched control approach. So this looks very encouraging for this matching design. But of course, this is just one example, right? So you might wonder, we were encouraged when we saw this, maybe with very large data sets, you can get this kind of methodology to work. But you might wonder, well, this is one case, like how do you know this? You didn't just get lucky or manage to find something that happens to work here. Does this work more generally? And so what we've done next is replicated the same approach for 13 different programs, where on the vertical axis here are estimates from randomized trials. And the horizontal axis are estimates based on exactly the same matching approach that I showed you on the previous slide. And you can see these things are amazingly well related. So you can pick out which programs, each of these dots represents a different job training program in a different city, right? So the dots on the far left, those job training programs don't look very effective. The ones on the far right are incredibly effective. They're increasing people's earnings by $20,000 a year. And you could have figured that out perfectly using this matching approach without having to run the randomized trial. So this really looks quite promising in general. But moreover, from a data science perspective, I think what's important, especially when you have this much data, is not just to test the null hypothesis of whether matching works or not. Obviously, if you have enough data, you're always going to reject the null that it perfectly matches some experimental benchmark. What's really important is how big are these errors, which you can now measure if you have enough of these estimates, right? You can basically ask, what is the deviation of the matching-based estimates from what you would have predicted, from what you get from the experiment? And that can give you a sense of the distribution of these matching errors, which is useful in understanding how confident you can be in these sorts of estimates going forward if you think that these sites are exchangeable in some sense. And so, concretely, what you find here, if you just use these simple comparisons, is a root mean squared error, an average error estimate of about $1,200. So the discrepancy between the matching-based estimate and the experimental estimate is about $1,200 on average. That actually overstates the true error because there's some noise in the experimental estimates themselves. You can adjust for that. If anything, this is somewhat conservative. The point here is that a $1,000 miss is not that big of an error relative to the range of programs we have here. So there's quite a bit of information that you can glean from this matching approach. Now, I want to make one final methodological point here before coming back to the economic implications of this. So for those who are familiar with the literature on causal inference, and this in some ways goes back to Hito's work and the credibility revolution and so on, back in the 1980s, there was a lot of concern that these sorts of methods don't work when people were implementing these kinds of matches with much smaller survey data sets that were available at the time. So why is it that we get such different results here? So let me just walk you through this slide that shows you what's going on. So I just showed you that if you do exact matching in a data set where you have 170 million observations in the control group, in the potential set of controls, you get an average error of $1,200. Now suppose you did the following exercise. Suppose, as in work that Hito's done with another one of your colleagues here at Stanford, Yiqing Xu, in a nice recent paper they have in the Journal of Economic Perspectives, replicating some of these earlier matching methods. Suppose you did propensity score reweighting in a smaller sample with only 16,000 observations and impose a more parametric model of the type that Bob Lalonde and others were using at that time when you could not have these incredibly flexible models because you didn't have enough data. You get triple the mean squared error in the set of programs that we've been studying here, which is what you might expect when you have a much less flexible model to find those matches. There's some other work, trying to augment that model by Deheja and Waba. There's a debate in this literature about different parametric forms. That turns out not to change things very much when you include additional earnings lags. So this is doing these kinds of parametric models in small data sets. Now suppose you implement exactly those propensity score methods in much larger data sets. So you use the same statistical models that people were using in the past, but now in a data set with 10 million observations. That basically does nothing to the root mean squared error, right? So it's not about the sample size in and of itself that's helping us. It's the sample size coupled with the fact that that then allows you to fit a much more flexible model and find those exact matches that dramatically improves the performance of this approach. Okay, so why have I gone on this whole methodological detour to describe this approach? It's because I think it can be very valuable going forward in the social sciences to figure out which kinds of interventions actually make a difference. And so to give you an illustration of that, I want to turn back to the Year Up program and show you how the estimated treatment effects of this program vary greatly across context. So suppose first that you were only willing to learn from the randomized trial. Remember, the randomized trial was run in 2014. The only data you would have is that the Year Up program, as implemented in 2014, increased people's earnings by about $9,000 a year. But with the matching method, you're not confined by when you ran the randomized trial. You can do that matching method for any other year as well. The program was started back in 2008. It continues today. You can do the same method in any year, right? And so what you end up finding when you do that, just using the observational data on who participated in Year Up and implementing this matching estimator, is this very interesting result that the program has basically become more effective over time. So it's something that you might expect, if you're running a business, you basically perfect your business model over time. If they had run a randomized trial back in 2008, they would have, I actually think it's a good thing they did not do that on scale. You would have found that the program doesn't seem that effective at that point. That might have killed off its growth. They smartly waited until they had a sense of what they were doing, got a much bigger impact, and you can see it's since grown quite substantially. This is not information you could have had purely from the RCT. It illustrates why using RCTs to validate observational methods in the age of big data may be a useful way to proceed. Moreover, it's not just that you can learn about how these effects vary over time in the aggregate. You can also see how these things are varying across sites where you're operating these programs. So here's the same data in one city where Year Up is operating, where you're seeing the steady growth of impacts over time. Here's the data for another city where they're operating, where for whatever reason, it's totally a flat line. And they're not getting better over time. And providing this information back to their group can both help them retool and understand what's going on here versus there, and more generally allow us to allocate resources to the programs that have the highest rates of return. And so stepping back, what do we learn from these kinds of exercises? What we found basically on the economics of this is that these job training programs that provide that additional social support, that are in sectors that are growing rapidly, they can be really effective ways of launching people on pathways to upward mobility. So last point I want to make before wrapping up is just to briefly say what I think we can do on the other side of this picture. If we focus on institutions like Stanford and Harvard, what is going on there? How might you increase economic mobility by shifting those dots over to the right? And here, again, we and others have done quite a bit of work on this issue. One simple point I want to make is we've done some analysis using essentially quasi-random admissions off the wait list, where we show that these dots are way up there, not just because of selection, but because of causal effects. Essentially, if you compare the outcomes of a kid who narrowly gets into Stanford versus a kid who goes to Berkeley, it turns out that getting into Stanford basically doubles your odds of reaching the top 1% of the income distribution and achieving success on many other metrics. So that, empirically there's a very clear impact of attending some of these institutions. And that comparison, I think, is of interest because obviously Berkeley itself is a fantastic institution. If you compare Berkeley to other schools, there's a big treatment effect of attending Berkeley relative to other colleges. And so, the first point is that it really matters that this is not just about selection. There's a treatment effect of attending these schools. The second point, and I'm just going to skip some details here on how we reach that conclusion about causal effects, is that if it matters if you attend this college, but who gets to attend these colleges is very skewed by parental income. So if you go back to the earlier part of this talk, one view you might have is, well, it's no surprise that Stanford has many more kids from high-income families than low-income families, because there are all these things we've been talking about the neighborhoods in which kids grow up, the K through 12 schools they attend, who they're connected to, et cetera, that might really change your trajectory before age 18, before you apply to Stanford. But our sense is that even at age 18, even when you look at the point of college application, there are significant things that you can do to level the playing field. And that's shown in this plot here, where what we've done is linked data on everyone's SAT and ACT scores to the tax records and to colleges' internal admissions files, and basically asked, what are your odds of attending a place like Stanford or Harvard, an Ivy Plus college, versus your parents' income percentile for a set of kids who have exactly the same SAT score, all of whom score at the 99th percentile on the SAT, which is an SAT score of 1510 out of 1600. So among that set of kids who in some sense have the same academic qualifications, what are your chances of attending a place like Stanford? And it turns out that if you happen to come from parents in the top 1% of the income distribution, those odds look like something like 40%. If you happen to be from the upper middle class, they look more like 15%. So even among kids with exactly the same academic credentials when they're applying, there are enormous differences in terms of your chances of attending these colleges. Why is that? It turns out it's because of things like weight placed on non-academic credentials, extracurriculars, legacy admissions, athletics, other non-academic factors that are driving these differences by parental income. And so I think there is something colleges can do potentially to expand access, which would have an important impact on economic mobility. I also think that this underlies some of the frustration that people feel with elite institutions, that these are springboards to the elite in the United States, to the top of society, which is in fact true, but they are also restricted in terms of their access to people from certain subgroups. And I think that can generate a lot of tension as well. And so I think there's more we can do in this space to increase mobility going forward. So let me wrap up by showing how this work, I think, matters not just from a scientific perspective, but can actually have an impact in the world, especially for the students and the younger scholars here. Many people often ask me, like, this is all interesting, in a politically polarized time, does any of this actually have an influence on what people are doing on these issues? Does science matter in this context? And so I just want to leave you with a few examples of how I think this kind of work can really make a difference related to the set of results I've shown you. So I'll start with examples from the affordable housing space, where I showed you that data from the Creating Moves to Opportunity experiment in Seattle. After we ran that study, the Housing and Urban Development Agency, Congress passed a bill to authorize $75 million to replicate what we did in Seattle and 8 other cities in America. That was done as an experimental demonstration, and recently the results were released, and they were able to show that you find similar effects from that kind of social assistance, that increased move to opportunity in those 8 other cities. And there's now a bill with bipartisan sponsors, a Republican and Democratic senator, that proposes to expand the housing voucher program by $5 billion per year, would add 250,000 vouchers, would have a significant impact on many kids' lives. And our sense is, because there's bipartisan support for this at some point, this may be passed into law as well, and would have significant impact directly as a result of this kind of work that people have done. Second example, in the context of higher education that I spent some time on. So just simply documenting the fact that rates of economic mobility vary dramatically across colleges, and this is something we should be interested in, led to changes in how colleges are ranked by things like US News, putting some weight on economic mobility. As I emphasized earlier, a lot of this class difference in terms of admissions to elite colleges emerges from non-academic factors, as opposed to things like standardized tests like the SAT. That kind of data was very relevant in colleges reinstating the use of standardized tests in admissions, which some of you might have seen recently. And then, fleshing out in the data how admissions practices of elite colleges can tilt in favor of wealthy students with non-academic ratings, legacy admissions, and so forth. You again see concrete responses to that. Yale has started to use the Opportunity Atlas data to contextualize applications in its admissions process. Some of you may be aware that California and other states have banned legacy preferences in admissions. And so you can see there's a direct through line from this kind of data analysis to what people are doing in the higher education space as well. And then one final example, which I'm most excited about, we're seeing lots of cities in the US make concerted efforts to try to increase economic mobility using this sort of data. So I mentioned early in the talk Charlotte, North Carolina, as a place that has particularly low levels of economic mobility. When we put that data out publicly, they responded in a very constructive way. They set up a task force and a commission to try to coordinate people to increase economic mobility. Bank of America, which is headquartered in Charlotte, teamed up with Year Up, the job training program, to invest $160 million in workforce training programs to hire people from disadvantaged communities in Charlotte. The city collaborated with local nonprofits to invest about $250 million in various childhood education initiatives. And more broadly, they're trying to monitor this systematically as a goal going forward. And so those are just 3 examples of more broadly how I think even in this polarized time, there is tremendous interest in using data and using science to try to improve economic opportunity across the United States. Our team has found tremendous interest in people wanting to engage with these issues across the United States, as you can see in this map here. And so I hope that leaves you with the message that, even at these times when the value of higher education institutions, the value of science is being questioned by some, I think that science in general and data science in particular can provide a path for progress and provide a path to address some of the challenging issues of our time. Thanks so much.
First, thank you. It was a great talk. It's exciting stuff. And thank you also for your contributions to society. I think this is an exciting thing.
Thank you.
I wanted to go back to the very first slide that you
Sure.
showed, where you had that graph from 92% for more than 40 to below 50% for the more recent one. I wanted to know if you were to take that and also chart for Germany and Japan after the war, and then maybe Taiwan and South Korea, which are a little bit later in their development, and then maybe even China.
Yeah.
You see the same shape of the curve?
Yeah.
Is that kind of a durable pattern, and is that more of a macro effect that's related to your economic development and productivity slowing down, and then you kind of the rest of your talk got into these more micro types of things.
Yeah. Great set of questions. So, and there's a lot one could say about it, so I'll try to summarize briefly. So there are other scholars who have built on the work that David Grusky and I did in that initial chart to do this for many other countries. We don't always have the data to do it for every country, but for really a large set of countries, Robert Manduca, Jonathan Berman, and others have constructed these sorts of statistics. In a nutshell, what you see is that the US and UK are kind of remarkable in terms of the magnitude of the decline. You see declines in many other developed countries as well. In developing countries, you can get different patterns, even increases in some places as you're intuiting, as they're growing and so on. What your question gets at in terms of the economics, more fundamentally, setting aside just the cross-country comparisons, is how much of these trends in terms of what we call absolute economic mobility, what fraction of children do better than their parents, how much of it is just driven by changes in growth rates, changes in the size of the total economic pie, versus the distribution of that growth. So as you suggested in your question, of course, changes in growth rates as a whole will matter. If the economy is growing more slowly, fewer kids are going to do better than their parents. In the US, as many of you might know, in the past 30 to 40 years, GDP growth rates have been about 1% lower than they were in the middle of the last century. And so surely that is part of what's going on. We do a decomposition in our paper to ask how much of the decline in economic mobility is due to that effect versus a very different effect, which is changes in the distribution of growth. So just to see intuitively why that might be important. Suppose we have the same growth rate, but all of the growth goes to the very richest person in the economy. Then we're again going to have a substantial reduction in the fraction of kids who do better than their parents, but in this case because of distributional effects rather than because of slowdown of total growth, right? And so it turns out in the US, 2/3 of the decline is because of the change in the distribution of growth, and 1/3 is because of the slowdown in overall GDP growth. And that's what leads to my focus on what I see as the determinants of that distribution of growth. Basically, why have wages stagnated in the bottom half of the distribution? I think it relates to a lot of the factors that we've been talking about here: education, access to social capital, and so on.
Hi, thank you for your
I remember, yeah.
It was really inspiring. I had a question about how you selected which variable to match on.
Yeah.
You showed other techniques, for example, they considered marriage, which I don't
Yes.
think you did. So
Yes.
how did you select those?
Yeah, great question. So, you can think about that in different ways. We found that once you have something on people's prior wage trajectories, it really didn't matter a whole lot what exact set of other variables you could look at. You get slight differences in mean squared error if you use different combinations of variables. But once you have detailed information on how people are doing before they participate in this program, along with some location information and, very importantly, exact age, because age trajectories, as the graduate students here will appreciate, your wages in your 20s are not necessarily representative of later in life, hopefully. And so that's extremely important as well. But then beyond that, it really doesn't matter a whole lot if you add other things. Now, you can come at this with more disciplined ways. As you know, you can use machine learning methods to pick a set of covariates, et cetera. But that basically seems to be what's going on.
Hi.
Sorry, where am I looking at? Please.
So I wanted to come back to the scatter plot of access and mobility.
Mm-hmm.
Many aspects are shaping university decisions. For example, ranking, alumni donors, wealthy alumni, different funding, for example, performance funding, prestige, etc. So universities want to keep their prestige, admit higher ability students, but on the other hand, we all know that many low ACS and other disadvantaged students, for intersection of different disadvantages, have lower SAT scores and lower other criteria of achievement.
Mm-hmm.
What if you met presidents of Harvard and Stanford, what they can do practically, not just we all want to increase success. What they can do practically that serves their best interest of prestige, but also practically possible to increase success?
Yes, so it's a very good question. Let me come back to the slide to answer that. So what I want to stress, you're right that kids from lower income families on average have substantially lower SAT scores, one measure of preparation at the end of high school, relative to kids from higher income families. And I think we should not be surprised by that, given everything that I've shown here. Kids from lower income families are growing up in much more disadvantaged environments, and you would expect that to show up in how well they're doing when they're 18 years old and applying to college. And so at some level, there's only so much colleges like Stanford, Harvard, Yale, et cetera, can do at that point. However, and this is the key takeaway from the slide, even conditional on SAT scores, right? So take a set of kids who have exactly the same SAT scores, there is still an enormous difference in your chances of attending these institutions. And I would argue it's this curve that can potentially be flattened, if so desired, by college presidents. And what is driving the slope of this curve? It's other measures beyond SAT scores, like your teacher ratings, the extracurriculars you had, what sports you played, and so on. All of those factors, I didn't show this to you here, but all of those factors turn out to be basically uncorrelated with measures of success later on. SAT scores are very highly correlated with future incomes, attending top graduate schools, other measures of success. And so we have talked to many college presidents and admissions deans and so on. And concretely, what I tell them is, there are trade-offs here where, maybe you want this sort of curve. There can be financial reasons that, You want to admit certain students from very wealthy backgrounds, et cetera. But setting that aside, it is not true that you have to make a trade-off in terms of merit, because there are clearly kids who are equally qualified from lower income families who would do just as well, who are not getting in. And so I think that part is something that's in college's hands and can be addressed through changes in policies like I was describing.
Hi, thank you for this presentation, Professor Chetty. It's amazing to see the impact and the broad domains that this kind of work can cover.
Thank you.
I want to talk about the last slide that you showed that showed the impact and the quantity of organizations starting to engage with this work and start to use this kind of research to change programs and policies. And even in that slide, you hinted that there's starting to be this growing skepticism of institutions and of data. And so much of your work necessitates working with a few select government agencies and corporations in order to have that national and those micro level analysis. What advice do you have for us as data scientists to be able to engage with potentially skeptical policy leaders, community leaders, just civilian society in order to actually move a conversation forward when there's this potential distrust?
Yeah, great question. Of course, data itself is the fuel for all of this being possible, for this building at some level. That's the basis of what we're doing here. And I mean, one thing that I think I've started to appreciate over time that I had not realized, about 15 years ago, I had the sense large data sets could help us understand these kinds of questions better. But what I had not appreciated is that they could be extremely helpful for communication to the public. And so you'll notice that, in a lot of the slides that I showed on the impact this kind of work has had, the key is really public dissemination. If you look at the left on numerous media articles covering this kind of research. And what I've found is one of the values of having these very large data sets is you can present information to people in an incredibly transparent way, where at some level, and there's something Hito taught me, that you can kind of think of econometric models or statistical models as essentially trying to solve missing data problems, right? And so when you have very good data, you can present it to people in the form of a map or just kind of essentially a certain set of conditional means that people can grasp very easily. And I think people being able to see, yes, I can use this information to look at my own neighborhood, how it's different from other nearby places or my own institution versus others, and here's the concrete impact of a change that we can implement. That can really lead to buy-in in terms of people wanting to provide that data access and act upon it. So I don't know if that's the solution in and of itself, but I think that sort of transparent communication of results can be very valuable in supporting further data use going forward.
So one more question. Thank you, that was fantastic. I'm delighted that you included such careful observation of a non-college program for adults. And I appreciate also your emphasis on value. I'd say that there's little question that as in terms of public provision in the second half of the 20th century, the United States really put a lot of its marbles in four-year college degrees and to a lesser extent two-year college degrees, and workforce training programs were in a different category entirely. And I'm wondering if from the view that you and Opportunity Insights have, how are you guys thinking about the relative investment in the public sector that the nation might be making in sort of legacy four-year and two-year degree programs versus alternative kinds of pathways for adults?
I mean, I think you're exactly on the right track, that thinking harder about modern versions of vocational training programs, workforce training, seems like a very valuable thing to do. These are relatively low-cost programs that seem to be having quite a significant impact. There might be other colleges that are also having these significant impacts. One of the projects we're trying to do at the moment is to measure the value added of each two-year and four-year institution systematically. Again, coming back to the methodological theme of this lecture, combining observational and quasi-experimental or experimental methods. And so we will see what comes out of that. But my sense from what I've seen so far is these kinds of workforce training programs can be quite valuable. The one caveat I would give here is that those, the potential knock on those programs is they train you in a particular skill that's valuable today. If the economy changes substantially in 10 years, it's possible that those skills become less valuable, and maybe if you had a broader set of skills that you would have gotten in a traditional degree, you would be more versatile. Again, that's an empirical question. I don't know if that's true or not, but before we go completely in the other direction, I would want to know what that looks like empirically.